Hi, I'm Eric Buck, broker with RE/MAX Properties of the Summit in Breckenridge, Colorado. This tutorial is about math associated with amortization and loans. It can be useful for people who are studying for their licensing exam or even for existing brokers that need a little refresher on their math. I'll try to go over some of the basic principles and some of the non-math issues that often crop up in math-related questions and trip you up. I hope you find this useful. First, let's look at the different types of loans. We have a fixed-rate, fully amortized loan. This is a loan that generally has a fixed term of 15, 20, 25, most typically 30 years, and has a fixed interest rate through the life of the loan. This is the most common loan that we see out there today. Second, we have variable rate loans or adjustable rate. These loans also tend to be for a fixed period, but their interest rate may change over time. Typically, it's static for 5 years or 7 years, then adjusts with the market interest rates, and usually there's a cap on how much the adjustment can be in a single year and over the life of the loan. Term or interest-only loans, typically with a balloon, are loans where, as it implies, you only pay the interest for a certain length of time, and then at the end of the loan, you pay back the initial balance. Home equity loans are loans taken out against the equity in your home. And finally, reverse mortgages are loans that are made over time to older individuals who have equity in their home, and they, in essence, receive a monthly payment from the bank that increases their mortgage amount month after month. We're going to focus most on fixed-rate, fully amortized loans, as that is the most typical loan and the one where most of the exam math surrounds. So with a fixed-rate, fully amortized loan, we have an interest rate that stays fixed over the life of the loan. Payment stays fixed over the life of the loan. The contribution to principal increases after each payment. The contribution to interest decreases after each payment. The loan balance reduces after each payment. And at the end of the loan balance is zero. So now let's look at this graphically. Here we have a $300,000 loan for 20 years at 5%. The payment on this loan is $1,979.88 in principal and interest. That's the blue line on the top chart. You see that stays constant over the life of the loan, which goes for 240 months. In the first month, $1,250 goes to interest, and only $730 goes to principal. But that $730 reduces the principal amount for the following month. So in the next month, our interest is calculated not on $300,000, but on $299,270. So we see interest go down $3 to $1,247. Our payment stayed the same, so our contribution to principal goes up by $3. And now our new loan balance is $298,537. So each month, we see the loan balance decline. We see the amount of the payment going to principal rising, the amount going to interest declining. So, how did we get to that payment number? Well, on your test, they're either going to give you an amortization table, which looks like this table here, or they're going to give you the amortization factor. The factor is the monthly payment per $1,000 of loan. So let's look at our example again. $300,000 fully amortized loan for 20 years at a fixed rate of 5%. Step one is to find out our amortization factor. So we go to the column with the years. Our years are 20, so we go to this column here, which is 20 years. And our rate is 5%. So we find the row that has 5%. And here it is right here. 6.5996. So for every $1,000 a loan, it's $6.59.96 in monthly principal and interest payment. So if we look at our loan, we have 300,000 loans, so that's 300 1,000s. 300 times our factor gives us a payment of $1,979.88, the number we had seen earlier. So let's look at a sample problem. Tony has a 30-year fully amortized fixed-rate loan at 4.75% interest. His purchase price is $475,000, and he's putting down 20%. What will his monthly principal and interest payment be? Well, again, we use our amortization table. And first, we find the factor at the intersection of 30 years and 4.75%. And here we see our number is 5.216. Now we calculate the number of thousands. Our house costs $475,000, but we're only borrowing 80%. That's 100% less the 20% down payment. So 80% of $475,000 is $380,000. That's our loan amount. So that's 380 1,000s. We multiply our factor times 380, and we come up with a payment of $1,982.08. Now let's look at another example. Bobby Borrower is considering two loans. One is $550,000 for 30 years at 5.5%. Alternatively, he can borrow the same amount for 15 years at 5%. What's the dollar difference in monthly payments? This is a very popular type of question on the exam. Well, again, not having the factors given to us in the question, we need the amortization table, and the exam will provide you with the table if they're not providing you with the factors. So, factor for 30 years at 5.5% is 5.6779. That times the 550,000s that we have gives us a payment of $3,122.85. So that's loan number one. Now let's look at loan number two. 15 years at 5% is a factor of 7.9079. Times the same 550, we have a payment of $4,349.35. The difference, $1,226.50. Now, kind of a shortcut for this same question is generating the same factor for each loan, 56779 for the 30-year at 5.5%, and 7.9079 for the 15-year at 5%. Then we just take the difference of those factors, which is $2.23 per thousand. We're borrowing 550 times the 2.23 gives us that same $1,226.50. This saves you a couple of calculations, but the other method may be a little clearer to some people as you go through. Okay, now let's talk a little bit about the difference between a banker calendar and an actual calendar before we go on to some additional problems. An actual calendar is based on 365 days and uses the actual days of the month for its calculations. So let's say we have an interest-only loan for $250,000 at a 5% interest rate. How much interest is paid in the first 2 months? Well, $250,000 times 5% is $12,500 annual interest. If we divide that by 365 days, we find our daily interest is $34.25. So January has 31 days, February has 28 days, for a total of 59 days. Our 59 days times that $34.35 gives us interest for the first 2 months of $2,020.55. Now let's look at this based on a banker's calendar. Banker's calendar uses 360 days and assumes 30 days for every month. So the same $250,000 loan at 5%, we see the annual interest still is $12,500, but we're now going to divide that by 360 days to get $34.72 per day in interest. January, we allocate 30 days. February, we allocate 30 days for a total of 60 days. 60 times $34.72 gives us an interest of $2,083.33. So you can see there's a little difference here. And here we have a side-by-side comparison. On the left, looking at the 2 months, Everything down to through the annual interest is the same, but the daily interest you see is different by some 48 cents. And the days are also different by a day. So we come up with about a $63 difference in interest between the actual calendar and the banker's calendar. On a full year basis, the numbers are somewhat closer. We see interest of $12,501.25 for the actual calendar, so about $1.25 more than you would expect. And on the banker's calendar, it's $12,499.20, so about 80 cents less than you would expect. Some of that is just rounding related as well. So you should know what your state default is in terms of whether they use the banker's or actual calendar. In most cases, the test will tell you which to use, but if not, you will have to know which one to use as the fallback. Most times, it's the banker's calendar. So let's take an example. Mike buys a home for $780,000 using an 80% loan to value and a 30-year mortgage at 5.25%. What is his mortgage balance after the second payment? Well, again, they didn't give us the amortization factors, so we're going to need to pull them off the amortization table. So the factor for 30 years at 5.25% brings us right here to 5.5220. How much is he borrowing? Well, he's borrowing 80% of $780,000, which is $624,000. So the payment is going to be $624 divided by 1,000 times 5.5220, or a payment of $3,445.73. So that's his total payment. How much of that is interest and how much is principal? Well, let's calculate the first month's interest. Our loan balance was $624,000 at a rate of 5.25%. So that's $32,760 for the full year. Divide that by 360. Remember, we're using the banker's calendar here. And we get $91 per day. 30 days in the month is what we default to in a banker's calendar, even though January is 31. So that's 30 times 91, or $2,730 of our $3,445.73 payment is going to be interest. What's the balance? The balance is the principal that we're paying. So that's the amount we're going to be reducing the principal balance. How much is that? $715.73. So our new principal going into the second month is $624,000 minus that $715.73, or $623,284.27. Now we calculate the second month's interest. Same 5.25%, but now on this slightly lower balance. Total payments for a year would be $32,722.42. Divided by 360, now we're at $990 a day, so 10 cents less per day than we were last month. Times the 30 days gives us $2,727 in interest. Payment minus interest equals the principal reduction, which this month is $718.73, which brings us to a balance of $622,565.54. So that's the answer to this particular problem. Typically, they don't go more than two months out. Most often, they're 1 month. Occasionally, you might see a 3 or 4 month where you have to keep repeating this same process as you go along. Okay, let's look at another version of this problem. We have Mike buying a home for $780,000 using 80% loan to value and a 30-year mortgage at 5.25%. How much interest will he pay over the life of the loan? So we're talking about the same loan here. We had a factor before of 5.5220. Remember, that's again 30 years at 5.25%, 55220, times 624. Our loan was $624,000. 80% of 780 is $624,000. That gave us that payment of $3,445.73. Now we look at the number of payments. We've got 30 years at 12 payments a year, so that's 360 total payments that we're making, each payment being the $3,445.73. We end up paying $1,240,462.08 over the life of the loan. Now, the original loan was $624,000. So what's the difference between the two? It's the amount of interest he paid. $616,462.08. Okay, now here's one that can be a little tricky. You got to pay attention to. George buys a home for $790,000 using an 80% loan-to-value ratio and a 30-year mortgage at 6%. The home is appraised at $740,000. How much is George's monthly payment? Well, let's start out with a factor. 30 years, 6% gives us a factor of 59955. Now we want to determine the loan amount. Now, would it be 80% of $790,000? Well, that's where the trick comes in. The home's only appraised at $740,000. So when we talk about loan-to-value ratios, it's the lower of purchase price or appraisal. So the loan is 80% of $740,000, not $790,000. Payment is 5.9955 times 592 gives us $3,549.34. Watch out for that trick. Here's another one. Jose is borrowing $250,000 for 30 years at 3.75%. He's doing pretty well in today's market. He's closing on September 18th, and his first mortgage payment will be due November 1st. How much prepaid interest will he pay at closing? And we're going to use a banker's calendar year here. Well, first thing to remember is interest is paid in arrears. That means that the November payment, which is his first payment, will include the interest for October. So he doesn't need to pay October's interest or prepay October's interest. But he does need to prepay for September 18th through 30th because they have not been paid yet. So the loan is $250,000 at 3.75%. That's an annual rate of $9,375. Divided by 360 is 2604 per day. And we're looking at 13 days. Now you may think, gee, September 30 minus the 18th would be 12 days. But no, on interest calculations, we always include the day of closing. And that happens on both the buyer and seller side. So 18th inclusive through the 30th would be 13 days. Times the 2604 a day would be $338.54, which he would have to pay in prepaid interest at closing. By the way, that would be a debit on the settlement statement to the buyer. Here's another one. Phil is assuming a loan with $550,000 balance that has an interest rate of 4.25%. Closing is June 18th, and the last payment was June 1st. How will the interest allocation show on the settlement statement? Well, again, remember interest is paid in arrears. So the June 1st payment paid for May interest. The seller owes interest for June 1st through 18th because the seller owned the house through the 18th. Loan is $550,000 times 4.25% is $23,375 a year. Divided by 360 days is $64.93 per day. And we have 18 days now that the seller needs to pay for. So seller owns the day of closing. 18 times $64.93 is $1,168.75 that the seller owes the buyer. How does that show on the settlement statement? It's a debit to the seller of $1,168.75 and a credit to the buyer of $1,168.75. All right, now let's finally look at down payment and points. Points are, in essence, prepaid interest. They can be paid by the buyer or seller, or in fact, any party. They decrease the interest rate to the borrower, and they increase the yield to the lender. 1 point equals 1% of the loan. So let's say we have a $300,000 loan, and the borrower is paying 1 point, that's $3,000. And a point lowers the effective interest rate by 1/8 of a percentage point. So if your loan was 4 1/4 and you paid 1 point, your new loan rate would be 4 1/8. Make sure you don't get these two confused, because these are frequent questions on the test. So our question on points: Wally is purchasing a $375,000 home with a 20% down payment, which includes his earnest money of $5,000. The mortgage is for 25 years at 4.75%. Wally is paying 3 points and has $4,075 in additional closing cost. How much cash does he need to bring to closing? Well, our down payment was 20%. So that's $75,000 right there that he has to bring. Our loan is $300,000. So the points on the loan, 3% of $300,000 is $9,000. That's another $9,000 he needs to bring to closing. He has additional closing costs of $4,075. But he did pay earnest money at the time of contract, and he doesn't have to bring that to closing. He gets a credit for that at closing. So that'll be a credit against the earlier numbers. So we have $75,000 plus $9,000 plus $4,075 minus $5,000, which is $83,075. That's what he needs to bring to the closing. Well, I hope those examples and explanations have been helpful. I'd love to get some feedback from you on what you'd like to see in these tutorials. Let me know whether I'm going too fast or too slow. And if you have any particular questions, you can email me at tutorials@ownthesummit.com.